Okay, so good day everyone. So my name is River ARLISS M. LONTOK, and this video will be all about the prototype demonstration for the thesis study entitled Monitoring of Peripheral Vascular Disease using Neuro-Fuzzy Algorithm and Wireless Body Sensor Network. So this prototype demonstration video will actually showcase two major things. First is the hardware demonstration or the demonstration of the fabricated prototype. And then there will also be a discussion of the web application attached to this prototype and its various features. Now, this prototype demonstration will mainly be conducted by my partner, Mr. John Paul E. JASPE. So I'll hand over the video to him.
The first device contains an RF24 module to receive data from the sensors. Then through Wi-Fi, the data from the sensors are sent to the server, which can be viewed on the web application. This next device is used to measure the ECG signal of the subject. It's a 3-electrode configuration and it's placed on both the arms near the wrist and another one placed on the right part of the body or the right leg. The other device is used for measuring the PPG signal of the subject. The finger is placed on the holder and it's preferable to use the index finger. Both ECG and PPG devices are battery powered and send the data wirelessly. These are the 3 electrodes that will be placed on the test subject. These are only used once and must be disposed afterwards. The plastic cover of the electrode is removed and the electrode will be placed on the wrist part of the right arm. The electrode must be placed properly because the signal can get noisy when it's loosely placed. The next electrode will be placed on the wrist of the other arm. The last electrode can be placed near the right leg and the cable is attached. The cables are attached to the electrodes on the wrists as well. To know that it's properly placed, a tick sound must be heard, which means that it's been attached correctly. After the cables are attached properly, we'll turn on the device that measures the ECG signal. As we turn on the device, we can look at the web application to view the raw ECG signal transmitted to the server, which is displayed in real time. We turn on the device for the PPG signal and the finger of the subject must be placed inside the holder where the LEDs are located. The finger must only be lightly placed on top of the LEDs and not too near or too far forward the holder to properly obtain a clear PPG signal. Once the finger is properly placed, we can look at the web application to see the PPG signal being transmitted in real time. It's time to record the ECG and PPG signals together. The details of the test subject can be entered on the left side. For testing, we'll just use a test user. It's indicated in the application that the recording has started and the time left for the recording. Once recording is finished, it is saved and we can view the processing of the signal. We displayed how the raw signals are processed and how the peaks are determined in this page to ensure the integrity of the signal that we captured. At the end, we can see the ECGR peaks and the PPG systolic and diastolic peaks. The ECGR peaks and the PPG systolic peaks are used to calculate the pulse transit time or PTT, and it is used to estimate the systolic blood pressure. While the ECGR peaks and the PPG diastolic peaks are used to calculate the R peak to diastolic peak time or RPDPT, and it is used to estimate the diastolic blood pressure. If we go back to the records page, we can see the estimated heart rate and blood pressure of that specific recording. We also performed the training of the regression model in the web application. We can view here all the records that we have and we can select the records to be used in the training. The computed parameters from our device are the pulse transit time PTT and the R peak to diastolic peak time RPDPT. The actual systolic and diastolic values used in here are obtained from commercial devices. After training, the graphs of the regression model is displayed. For the systolic blood pressure, our input parameter is the pulse transit time PTT, which is in milliseconds. As for the diastolic blood pressure, The input parameter is the R peak to diastolic peak time, RPDPT, which is also in milliseconds.